question arises that how you can, what is the statistical mechanism for the computation of alpha and beta. So statistically, it is use a least square method through which we can compute alpha and beta. And what are the formulas behind the computation of alpha and beta, the beta naught and beta 1, the intercept and the slope rather than. So that is actually in this session. Now we assume that the what is this least square actually? This least square method is following the minimize the sum of the square of the difference between y and y cap. The least square method is a mechanism through which we try to find out the value of beta naught and beta 1 such a way that could minimize the sum of the square differences between y and y cap. Like this mechanism is devised as such that we try to find out the minimum difference. We try to find out the value of beta and beta naught in such a way to have as close as possible results from the sample to the population. So this y is actually representing the actual population value, and this y cap is actually our predicted value. So this is known value and this is predicted value. So this equation is made as such that we try to minimize to find out the value of beta in beta 1 as such that we are having a minimum value of error, because the difference of the actual with that of forecasted will be having a minimum value of error. So this mechanism, the computation mechanism of the least square method, try to reduce the error of what? Error of the prediction from the actual. So we have this equation that is minimum value of the sum of y, actual value of y minus forecasted value of y square, which is equal to minimum, and y, actual y minus the forecasted y. This represents the forecasted y, beta naught and plus beta 1x whole square. And here also we have a whole square. So we normally take the first order derivative and second order derivative of these this equation, and we find out the value of the very uniform value of alpha and beta. So these are the first equation that we can take the first order derivative. This first order derivative and second order derivative will help us to find out the value, the formula that can be used to find out the value of beta. So beta 1 or beta 2, we call it here beta 2 in this slide. Beta 2 means the slope coefficient. The slope coefficient, the outcome formula that can be used for computation is like this formula. That where I personally prefer to use this formula because this is a simplified formula which can be easily computed in Excel or in any other packages. So summation xi, your original x value minus x bar, mean value of x, and similarly multiply it with y, actual value of y minus y bar. Y bar is actually the mean value of y, and then divide the whole by x minus x bar whole square. X mean the actual y, and x bar mean the x bar represent the mean value of x. And similarly, from this equation is actually derived. So we represent this whole section x minus x bar with small xi and y minus y bar with small y bar, yi. And similarly, x minus x bar square with the x summation x minus x bar whole square. So the better is to use this equation for the further calculation whenever you are asked to compute, or you should remember this formula for the computation of intercept. Now, how to compute the slope coefficient? For the slope coefficient, we have this formula. This formula, and the simplest one is the below formula, the last one. That shows that beta 1 or beta naught or simple intercept. Intercept is equal to y bar. Y bar mean value of y minus the beta that you have computed from this equation, this beta. Multiply it with the x bar, and x bar is the mean value of x. So you have a data, we can easily compute it in Excel in a few minutes. We can interpret this, computed this alpha and beta in Excel. And we have computed it, but we can manually even compute these formulas while using Excel. And I'm going to compute it in the later stage. Now, so for the computation of alpha and beta is concerned, that is okay. No issue. Let's have a computation of alpha and beta in Excel while implementing that formula, these two formulas. and then we are moving towards the t value, f value, r square, and the rest of the values. Okay, let me have this value. Actually, we have been given a very good leverage by these packages, so no one is going to use a simple computation by hand or either by using these formulas that we are actually following. Rather than we follow the software, but you should have understanding of what has been actually how we can calculate these. So first, we are going to calculate mean. Like, you know, before going to calculation of anything, you must know that what are the components that I need to compute. So number one, I have component. What are the component? X, I have X. I need to find out X bar. Okay, I will find out X bar, so I will be able to find out X minus X bar. And similarly, I have Y, but I do not have Y bar. So I need to find out Y bar, so this section will be computed. Okay, next. I have X and X bar because X bar is computed here. I just will be required to find out the X minus X bar whole square. Okay, this one. And the second one is almost I have Y bar and I have X bar and I will need to compute beta. So let's have these two equations in computation. Okay, the first one is I'm just going to make it X minus X bar, X minus X bar. Okay, and then X minus X bar whole square, because I also have a square of the X minus X bar. I'm just going to, for these, I'm just representing these like this way. And then similarly, I will be required Y minus Y bar, because Y minus Y bar, the mean value of Y. And then I also required the two, combined value of the two, a multiplied value of these two. So I have put it over here, the first one, let's copy and paste here, and then also copy and put it in a bracket because we are going to multiply these. So multiply these and multiply it again with bracket and then paste. Simply paste it here. This thing is giving error. Copy and paste. No problem. We will type it. Y minus Y bar, and then close it in bracket. Okay, these are the ultimate different tables that I have actually required. So first of all, I'm going to compute X bar and Y bar. So how to compute? This is actually the mean value. So I'm going to find out the mean value. How to find out the mean value? Okay, let me focus it so that, you may have more visibility. Simply just click on it and you just type mean or average, not mean, sorry, average, and you will get the average value. Select these all values and then click on this, you will get the average value. Okay, and similarly you can even copy and paste it here, you will get the same average value of this set. Okay, next, the next step is to find out X minus X bar. What is my X value? This is my X value. Okay, and my X bar is how much? My X bar is come down to this value. Okay, I can click, or I can simply type it, even 17, 15. So I will type it 17, 15 will be better if I type it 17, 15. Okay, and then click. Okay, same values. Okay, drag it down. So you will have the X minus X bar values. Okay, we are done with. Now we want to find out the square of this value, because in one time we also need a square. How to compute square? Shift and 6. This will give you this option, and then click on 2, because we are going to take a square of it. So then click, you will get this value, and then drag it down. This is computed. Now the next one is we want to find out the Y minus Y bar, and how much is the mean value of Y? 286.5. 286.5, and then click on it and then drag it. So you will have these values. Now we need a multiplied version of this. This multiply with X minus X bar. So we have these values. Now we are moving towards the formula, that how to compute the value of alpha and how to compute the value of beta. Now let's see, have a formula. The formula shows that we need X minus X bar multiply Y minus Y bar. We have computed this section. what we need is actually summation. And we will be also required the summation of x minus x bar whole square. So we need the sum of this cell, we need the sum of SUM, sum of this, we need the sum of this, okay, it has been sum, and we need also the sum of x minus x bar whole square. Yes, we also need the sum of x minus x bar whole square. Okay, now we have the sum square of both. These are actually the two values that we need to find out or to compute the value of beta, the value of beta, the value of slope. So slope is equal to, how much is the value of the slope? Slope is equal to, now I can simply take this value, this divided by this, and this will give me the value of beta, and which is the same as that we have already computed through the software, through the Excel. Like you can see it here. What is the value of the beta? What is the value of the coefficient? You can see it here. It is 10.10977, and again we have got the same value here, 0.10799 with a more decimal point. Okay, another simple method of finding out the slope. Slope is equal to, you can simply write down slope as SLOP. Even it will work. And you first give the y values. What is the y? You should define it y. What is y? So this is my y variable. Okay, I have defined it y. Okay, and then comma, and then you define it x. What is your x? And you define it x. Okay, and then close the brackets. You know, slope, you have given y and you have given x, and then click, you will get the same slope value. You can see it. So you can simply, but we are actually following the statistical process at how that formula has been implemented. So I have just shown you that how we can find out the slope. Now the question is how to find out intercept. We are moving towards the intercept. Now how to find out intercept? Very simple. We need x bar, we need y bar, and we need this slope. You can see the formula. The formula tells you that what you need. You need y bar, y cap, y bar minus y bar mean value of y, and the beta, and then the mean value of x. So I simply make the like this is simply, let's go up and find out. My first is y bar. This is the mean value of y. Okay, and then I will open a bracket because definitely I need to open a bracket. Multiply beta. What is your beta? This is your beta, and multiply it with what? With your mean value of x, and then close it. And then close it, and then you also start the bracket over here, so it will be better. And then solve it, so you get the 98.24, and which is the same as that has been computed with the original test through the package. So these formulas can be used to compute the value of alpha in beta, and I've showed you how this formula can be estimated. This is the way that how we can compute this formula. So you have one exercise, you will be having data to compute the alpha in beta, and you will compute it the same. I will share this template. Okay, and similarly you will also perform the same test on Stata and as well as in Excel, and we'll compute the result, and we'll put the result in a simple MS Word file, and we'll interpret the results. Okay, the next question is, like, this was half of the battle. Like so far, you have almost learned that how to compute alpha and how to compute beta. Now the next very much important question is that how much this beta is representing the true population beta, and how reliable this beta is. Like, computation of the beta does not mean that but you have find out a value and you can now use it for forecasting. No, you cannot use it for forecasting. You will be need to now validate the beta. You will be now confirming the beta, that the data based on which you have computed this beta is representing the whole population or not. So how we can know about this? Like in the early start of the class, I have given an example that, for example, I cannot consider population. Rather, I will collect data from the sample. So in your class, there are 50 students, for instance. I assume that I cannot collect data from the 50, and that is the population of your class. I'm just going to collect data from how much? from how many students? I'm just going to collect data from only 20 students, and I will collect beta. Okay, computation beta. I will collect data and then we'll compute beta. So computation of the beta does not mean that this beta is representing truly the population, the whole of the class. Okay, what I will be required now, I will be required to compute the t-test. So t-test shows that the beta that you have computed based on a sample of data, either it is representing the whole population or not. Either this beta can be generalized to the whole population or not. If the t-test shows that yes, it can be generalized to the whole population, then the next step is forecasting. You can go for forecasting. But if the t-test shows that no, your computed beta is not representing the population, okay, so then you cannot go for forecasting, and that beta is not going to be used for forecasting. If still you are going for forecasting, so it is actually your result will be misleading and your policy will be totally failed. So now the next step after computation of the beta is to compute the t value, t-test value. T-test is actually a type of statistical test that shows that either the beta is statistically significant or not. What do you mean by statistical significance? Statistical significance means that this beta that you have computed is a representative beta of the population or not. If this beta is a representative beta of the population, which means that the t-test result will be significant. And then later on you can go for forecasting. If the statistic shows that no, your beta is not representing population beta, so you should stop here, and you should again, it means that you have taken a wrong x variable. That's why x variable is not showing changes in y. The variable that you have considered is wrong, and you should go back and you should consider another x variable. Okay, and then again collect data and then test that, either compute beta and then perform t-test that either truly the y variable is affected by x or not. So the reality or truthness of the effect of the x on y is actually can be computed with the t-test. So t-test, let's have a t-test. What is t-test, how to compute t-test, and how to interpret t-test? This is actually now our session. T-test is used to check the sample beta can be statistically and significantly represent population beta or not. This is what I have discussed earlier. The significance of this test will show that there is a sufficient evidence that x variable affect y variable. So if you got this sufficient evidence, then in that case your model is okay and you can go for prediction. But if you fail to get this sufficient evidence from this test, then it means that you cannot forecast y on the basis of the x values, and there is actually problem in the theory. The variable that you have considered from the theory is the x variable. It means that this is not working. And you might have studied, or you will study in the research methodology, that there is applied research. In applied research, we test theory. Either we accept theory or we reject theory. So if you find out that this t statistic is insignificant, it means that y is not explaining changes in x. It means that the theory is failed to explain this phenomena, and we need something new. Okay, this is done by comparing t calculated value. Now how we will do it? Now this shows that the mechanism, this was the definition, this was the use of how the t-test shows, and this is how you will take decision that the sample beta is representing population beta or not. So how you will do it? This is done by comparing the t calculated value with the t critical value. So it means that you will be having two values of t-test. Number one value will be the critical value. The critical value is the tabulated value. There is a well-defined table which is given in Google and every book of econometrics. You can see it in econometrics, even you can Google it. T calculated value. This is called student t-test. Student t-test calculated value. So you will have the calculated value at different level of significance. In the research, we normally use 95% level of significance and 99% level of significance. It means that we accept 5% error, and in this case we accept 1% error, and we says that 95% we are sure that if we draw sample time and again from this population, and we will calculate the beta, so our beta will be representing the true, the sample beta will represent the population beta. Only 5% is a chance that if we do sampling, so only 5% in such instances we will have that the sample beta may not be represented population beta. And similar in case of 99%, in case of 99%, I'm saying that out of almost 100 sampling, if I do 100 sampling, 99 out of the 100 sampling I will have a beta that will be representative beta of the population. Only 1% will be such instance where the sample beta will not be representing the population beta. So this is a chance of error in our results. So this is representing a level of significance. So we will test our hypothesis at 95% level of significance. Mostly in social sciences, we test our hypothesis at 19 and 95% level of significance. You might have observed when I was actually giving data in the Excel, so there was actually a confidence interval, significant level. I have given 95%. So this is the reason that I want to test it at 95%. Okay, where rule of thumb, let's make it more simple for you. You need not to go and see a big table for that. I make it more simple for you. You just simple remember this sentence, that at 95% level of significance, the T critical value is 1.96. From the table rule of thumb, we generally assume that in case of large sample, we assume that at 95% level of confidence, the T critical value is 1.96. The T critical value is 1.96, and the T calculated value will become from our computation, and we have computed that in our table, and I'll just show you in few seconds. So you must remember these values, that at 95% level it is 1.96, and 99% level it is 2.33 as a rule of thumb. Now let's have how this T value is computed. What is the formula of this computing this T value? So this is the formula of computing this T value, and these are the hypotheses. Below are the hypotheses, that how we can develop hypothesis and how we can test hypothesis. So do remember these hypotheses are how to develop hypothesis and how to test hypothesis. Let's have a look of that. T-test for a population slope. Is there any linear relationship between X and Y? So your hypothesis, what is your hypothesis? Your hypothesis is that the beta naught, H naught, your H naught is null hypothesis. Your null hypothesis is saying that the beta 1 is equal to 0. The beta 1 is equal to 0 mean that there is no relationship between X and Y. You can state hypothesis like in this way, that there is no significant relationship between X and Y. Okay, like beta 1 is equal to 0 mean that the coefficient value is 0, is statistically insignificant. Or in simple words, you can even state the null hypothesis. It is not necessary that we should state that beta 1 is equal to 0. You can write here that there is no statistical significant relationship between X and Y. You can simply write it like in this way, H naught, there is no statistical relationship between X and Y. You are dependent variable, you are independent variable. And you are H1, for always you should remember, like you should interpret the hypothesis, you should state the hypothesis like in this way. Your H1, beta 1 is not equal to 0. It means that the beta value is significant. This beta 1 is representing the population. This can forecast the population. So in statement form, we can state that there exists a relationship between X and Y. Okay. So now we have H naught and we have H1. And now we will supposed to decide about which one is accepted, which one is rejected. So now how to accept H naught and when to accept H1. So there is a criteria. The criteria that I have mentioned, how we will accept H naught and how we will reject H1, how we will accept H1 and how we will reject H naught. There is a criteria. What is the criteria? The criteria is this. This is done by comparing T calculated value with the T critical value. Now we will compare the T calculated value with the T critical value. Now I've already mentioned that the T calculated value are coming from the regression analysis, and the T critical values are known to us. what are the T critical value? At 95% level, 1.96. At 99% level, its value is 2.33. So now we have the hypothesis and we have T value. How to calculate this T value? What is the formula of T value, by the way? The very simple formula of the T value is divide standard error with the beta. Like we have calculated beta and we have a standard error. So divide beta with the standard error, you will get this T value. In our tables, you can see here, like this is our final output. You can see here that how we can compute T value. T value is equal to beta divided by standard error. This is your beta. Okay, this is your beta that we have already computed. And this is your standard error. You can see it in the computation table of the regression that we have computed. So divide this by this, you will get the T value. So this is our T calculated value. What will be T tabulated value? T tabulated value by rule of thumb at 95% is 1.96. So now compare T tabulated with T calculated. And how to conclude, how to draw conclusion, this is actually the conclusion. Okay, first let me show you, before going to the conclusion, let me show you the same T value in the two tables. Like in this Excel sheet we have computed, this is the T value. How this T value is computed, you can have a look. This T value is computed like by this. This is a beta divided by the standard error. So when you divide this by the standard error, you can get the T value. And this value is actually what we call T calculated value. What value? T calculated value. So we understand probably what is the T calculated value and what is T critical value. And T critical value is normally taken at 5% level of confidence. At 5% level, 95% level of significance. Okay. So far we are clear. I need your feedback that till now you are clear. If you are clear, so I'm going to towards the hypothesis testing. If there is any question till now, so you can ask question. Is there any question, please? Any confusion?
No, sir, it's clear, sir.
You are clear. Okay, thank you. Now, if there is no question set, so I'm going forward with the T, how to now interpret this T statistics. Like we have developed two hypotheses. Based on this T statistic, we will decide about that either H0 should be accepted or either H1 should be accepted. And I've mentioned that what H0 or H1 shows. H0 shows, like for instance, let me state the clear hypothesis that this shows that there is no statistical relationship between your X and Y variable, between dependent and independent variable. Okay, and what your H0 shows, what your H1 shows, your H1 alternate hypothesis, what this shows, that there is a statistically significant relationship between X and Y. Okay, this is actually shows a statistical significant relationship X and Y. Now we are supposed to decide based on the value of the t-test that either we are going to either our result shows that yes, the relationship is statistically significant, or the test shows that the relationship is statistically insignificant. So now we can test for these hypotheses. Okay, what is the hypothesis? Our null hypothesis. Null hypothesis is what? There is no statistical relationship between X and Y. An alternate hypothesis state that there is a statistically significant relationship between X and Y. If we accept beta 1, we accept H1, it means that our theory is okay and we can go further for forecasting. There is a significant relationship between X and Y, and X can be used to forecast the value of Y. So this is actually the real essence of this test. Okay, now when we will reject H0, but do remember when we are going to reject H0. H0 will be rejected when there is a sufficient evidence that the square footage affect the house price. No, H0 should be rejected when H0 should be rejected. The decision, like in this case, the decision is that H0 is rejected. But how we can state, how we can know that yes, we have rejected the H naught. So for that purpose, there is actually a very simple interpretation for that. I'm just going to write the interpretation for that, that how I can say that I have rejected the H naught. So the rejection of H naught, how we can say that H naught is rejected or H1 is accepted. So for that, I'm just going to write out a very simple statement for you. A very simple statement that will make you clear. If the T statistics, T state calculated value is greater than the T statistic tabulated value, T state tabulated value, rather than tabulated T state critical value. So what we will do, we will reject, what we will do, we will reject H naught and ultimately accept H1. This is the way like how we can simply test our hypothesis. This is the statement, like how you will know that when I should reject H naught and when I should accept H1. So this is a simple interpretation, and vice versa. Okay, vice versa. How vice versa? For example, you may have a situation where the T calculated may be smaller than the T tabulated. So in that case, we will do what? We will accept H naught and reject H1. So do remember, like this is the way like how we can interpret the results. Like for example, if we can see the results for beta, for square fit, the beta is significant, because in this case, let's have interpretation. If the T, okay, let me have an MS Word file and interpret the results. It will be better. Or I can open this data results and interpret it. This will be much more better. Like how to interpret T. This is regarding the interpretation of T. Now let's see how I'm going to interpret T. Okay, how I'm going to interpret T, or how you will be supposed to interpret the value of T. Now I have just simply stated a statement, and I need this statement because this is the statement based on which we normally take decision. So let me copy it. And this is actually one statement, and similar I'm going to state the second. If the T state calculated value is less than the T state critical value, so in that case, what will happen? We will accept H naught and reject H1. Okay, so this is how we can find out that either exception and rejection, and then what will be the interpretation. Okay, now I'm going to tell you the real interpretation, that how you will interpret the results. Okay, this will be the interpretation. The T how to interpret the T statistics. Now I will say that this is purely a research oriented interpretation. Okay, I will say that okay, the coefficient value of the T is this, and its T calculated value is this. Okay, let me interpret it. This is for hypothesis testing. Okay, how to test the hypothesis? These are the simple understanding. Whenever you have a situation where your T statistic calculated is greater than T critical value, so you simply reject H naught and accept H1. Now how I can interpret in a real sense? Like I need to interpretation like in this way: is the T calculated T states calculated value is more than the T state critical value at 5% level of significance. Okay, at 5% level of significance. Therefore, we reject the H naught, that is, there is no relationship between the square fit size of the house and the price of the house. Or you can take any of your variable, price of house, and accept the H1. You can say alternate hypothesis, that is, here is statistically significant relationship between the house or size of the house with price of the house. This was statistical interpretation. Okay, we have done statistical interpretation. Now what is next? Your discussion. How you can do the same interpretation for paper. Whenever you are going to write a paper, you will run a regression and you will do the same interpretation that I have already did. But this was statistical interpretation. Now you will need to add something more. These results shows that size of the house is an important variable that can help in predicting the price of the house. Increase in the size of the house will have a positive impact on the price of the house. So this is a real interpretation of a particular beta. The test that the value of the t-test. Okay, so this is how we can interpret the t-test. Take simple these interpretation and put it in a piece of paper, run a regression in among any variable and interpret it. This is the real interpretation that how we can interpret the value of t-test. I hope that it will be clear to all of you, and hope that you have learned how to interpret and how to run the t statistic, the t computed value, or the t calculated value, critical value, and you can differentiate between t calculated value and t critical value. Okay, let's interpret another one, the constant one, the alpha one. Okay, can anyone interpret this one? Okay, let's see. Let's say if I'm going to interpret this constant alpha one, so how I can interpret? This is interpretation of intercept. This is interpretation of slope. This was interpretation of slope actually. Now if I want to interpret the intercept, how I can interpret the intercept? Now can anyone, let's have the constant value is this and its t value is 1.69. Now this is interesting case. The t statistic value, calculated value of the alpha or constant or intercept is less than the key state critical value at 5% level of significance. Okay, so now how we can the level of significance. So what we conclude, so we accept H naught, or you can even write it, we fail to reject H naught. The better way is we fail to reject H naught. So ultimately we accept H naught. Okay, so we accept H naught and reject the H1, which means that intercept has no statistically significant value for the price. In this case, we do not need to include alpha in the model, in simple words. In this case, inclusion of, I guess this interpretation is enough. We are least interested to interpret the alpha. Our interpretation mostly centered around the interpretation of the slope coefficient and the beta, because we make our forecast based on the beta. So that's why we mostly focus on interpreting the coefficient and the beta. So what you will be required, we can see the results even in all of the packages, the results are almost the same. So this is how we can determine that the beta is significant or the beta is insignificant. Okay, how we can find out the significance of the beta? The significance of the beta can be found out from t-test. Let me revise the whole again. How you can find out the significance of the beta? The significance of the beta can be found out from the t-value. When it will be significant and when it will be insignificant. The beta will be significant when you will have a t calculated value more than 1.94. If you have a t calculated value more than 1.96, sorry, more than 1.96, it means that your beta is significant. And your beta significant mean that this beta can help you to forecast, to predict statistically significantly for the population. If this value, t value, is less than, it means that you cannot use this model for forecasting. Now the question is, I have used the standard error. So how we can compute this standard error? So I have given the formula for the computation of standard error. Like if I want to find out the standard error, so for standard error, I will be required to compute the standard deviation. And standard deviation need the computation of error term. So we will get the error term, and then we will get the standard deviation, and then we will be able to find out the variance. And from the variance, we will get the standard error. This is actually much more statistical equations that if you want to have more understanding of it, so you can. But what we are actually interested more on the applied side, so that's why I'm not going to compute these in Excel. However, the different packages give the computed value of the standard error. This is actually the standard error. But the question arises how this standard error has been computed. So to compute the standard error, you need to first compute this value. This is a standard deviation. Xi square, we have xi square. Xi square is available. X minus x bar is actually xi square. Okay, but we need to compute this standard error, this standard deviation. So for standard deviation, we have a formula. We will compute this value, and for this value, we need to compute error square. So we will first compute error square, then we will compute this value. We will put this value in this equation, and we will get the standard error. So this is actually regarding the computation of standard error. The standard error divided by beta. In beta, we have the beta. We have learned how to compute beta. If you people are interested to compute all these in Excel, I can computed in the next class. You just have in overview of these formulas. If there is a problem, we can go and we can compute these formulas in even Excel sheet. Now the next test is F statistics or ANOVA test. ANOVA test for significance of the overall regression model. Okay, give me a feedback if you have got the understanding of how to interpret the t-test and how to test the hypothesis in t-test. Please let me know if you have any question or you have any query or you have any question. So let me know so that we can go further towards the F test. Do we have any query or any question?
Hamid said, so just a question, so you said 1.96 between the, so how do we know, Chera, the what is 1.96? But my question
yes,
is...
your question is very much a good question. And I was expecting this to be asked. This 1.96 is actually the critical value. We assume it like you can take the value from a table. Like I'll simply Google it. Okay, let me show you the actual table. This is, you just simply give it t-test critical values. This is actually the t-test table. Okay, this one is much more better. So let's have the one with the more big values. Okay, this is actually the t-test table. You can simply come and see the critical values from here. Okay, but for this you need two things. Number one, the level of significance. Like we have taken 5% level of significance. So this is your level of significance. Okay, this is z-test. Z-test and t-test almost have, z is normally used for a small sample size, t is normally used for small sample size, z is used normally for large sample size, but we have almost the same values. How you can see it in a table, like if you are interested to find out these in a table, how many number of observation you have. So you must know about your number of observation. If you have 10 observation, you have 11 observation, the number of observation is required and the level of significance is required. Let me have another good one table. Like this is this one is, yes, this one is more good. 95%. We are actually looking at 95% level. So the number of observations. So you must have here the number of observation and the degree of freedom, number of observation. We take the number of observations. These are the number of observations. But if you want to have a degree of freedom, so the degree of freedom is actually computed as the number of observation minus number of independent variable. So in normal case, you have observation in thousands and you have variable either 1 or 2. So subtracting 1 or 2 from 1000 does not matter. But if you have a small sample, then in that case you must subtract the my number of observations. This is actually your number of observations. That what I call the number of observation. Otherwise, it's a degree of freedom. So degree of freedom is the number of observation minus the number of variable that you have taken. So in our case, we have taken one variable and the number of observation that you have. So you simply take the number of observation from here and the level of confidence that you are using. We are actually having 95% confidence. Okay. So at 95% confidence, you will come down to the number of observations. You can see, you can take the value from here, but we are actually using a rule of thumb for a large sample size. We says that we are having a large sample size, and a large sample size, there is a rule of thumb that we should consider the value of t value as 1.96 rather than coming here and seeing it the table. So the better is to consider it as a rule of thumb, and that is 1.96. 1.96 is normally considered for a very large sample size. If you can see the number of sample sizes for 1.96 in at 95% level of significance, you can see it's 1000. Like we assume that for a large sample size, we have a value of 1.96, and large sample size means 1000. And at 99% level, you can see that at 99% level, we have the value of 2.5. 2.5. Yes, 2.5. But normally, we do not go for this table time and again and seeing all these things. So we normally consider it's a rule of thumb that a standard value, if that is the calculated value is less than that of the tabulated value, so simply I says that I will accept or I will reject. the null hypothesis, alternate hypothesis. So if you want to have you want to compute it through the table, so you can, like, a large number of tables are available around you, the number of observation, and then on the other side at 95% level of, and at 90% level of, you can see the appropriate value in this table. So if we can, for example, for instance, we assume that the actual value, rather than taking the standard as 1.96, we can take the original value. So you can see the degree of freedom. So how many observations we have? 10 observations. Okay, so 10 observations minus 1, because we have subtracted minus 1 because we have one variable, so 9. And then go towards the 95% level, 2.26. This value is actual value, critical value is 2.26. Now compare this 2.26 with your calculated value. Even if we take the original value, still our value is far greater than that of the tabulated value, critical value, tabulated value. So now again our hypothesis is actually okay, and we can conclude that yes, there is a statistical significant relationship between these two variables.
So we can say the T critical factor is used for the rejecting or accepting the hypothesis.
Exactly. These are the values. Based on which.
For example, अगर हमारा जैसे आपने कहा कि 1000 से अगर सैंपल साइज ज्यादा है या वेरिएबल को माइनस करते हुए जो हमारा इंप्रेशन या जो साइज आ रहा है वो 1000 से ज्यादा है, so the T value must be above 1.96 in order to accept or reject in order to be
in order to reject the null hypothesis.
Okay.
Exactly.
Thank you.
So we must have more than, but normally we do have a sample size of more than thousands. So that's why we are going for a general interpretation that if more than 1.96, so it means that your results are statistically significant. If less than 0.96, so it means that your results are not statistically significant. So we keep this benchmark. This is actually the lowest value of T value.
Just a question. For example, हम research कर रहे हैं या data analysis कर रहे हैं. At certain stage, हमारे जो भी हमने अपने for example अपने data sets बना लिए हैं, उसमें से किसी एक data set का let's say 1.96 से कम आ गया है, वो 1000 से ज़्यादा है और उसका T critical test हमने किया और वो 1.96 से कम आ गया. So what does this mean कि यार जो हमने hypothesis conduct करना चाह रहे हैं तो वो that's of no value, हमें उसके ऊपर काम नहीं करना चाहिए, so we should stop working on that thing या नहीं, हमने गलत चीजें सेलेक्ट की हुई हैं.
नहीं, अब दो बातें हैं. देखिए, आपकी very much good question. I got your question. Actually, the issue is that we are actually finding out the facts. So the facts can be whatever the data is actually telling us. It's not we cannot impose our own wishes that we want to have a significant or we want to have insignificant. It's the data that will tell me. For that purpose, for example, you have 2-3 variables. For instance, I'm just taking example of, like, you have just make I'll bring it in writing so that in order to oh no, we have an example. Okay, let me show you that example. We have a multiple variable. Let me show you that example. Probably it will help us. For example, like in this case, you can see we have more than 2 variables. Okay, and for instance, let's suppose that this advertisement is having significant effect on Y. Its T value, let's assume, is greater than, and price, let's suppose that is having insignificant. It is significant here, but let's assume. So it means that the theory is telling me that both of these factors are important. But in reality, in this particular context, in this particular situation, it's only the one factor, advertisement, that is being given preferences by my target audience, by my representative sample. So I should conclude, I should make a decision. For instance, if you have taken one variable, like आपने एक variable लिया हुआ है, and you are going to test the relationship, like in our case, and you find out insignificant relationship, it means that there is no relationship between these two variables. ठीक है, अब ये वेरिएबल आपने खुद तो सेलेक्ट नहीं किए, ये वेरिएबल के थ्योरी से आए हैं, ठीक है ना। और रिसर्च में हम क्या करते हैं, अप्लाइड रिसर्च में हम क्या करते हैं, वी नॉर्मली टेस्टिंग थ्योरीज, we consider a theory, we operationalize it into variables, and then we test a theory. So while testing, we come to the conclusion that this theory cannot explain this particular problem. The solution of this particular problem is not explained by this theory. So what I need to do? अभी मैंने क्या करना है, अभी मैंने जाना है और मैंने और theories देखनी है. So what are the other theories that can tell me that this could be the probable cause of this problem or probable solution of this problem? So I will consider those factors now. Clear, but like for example, now there was a situation that we do not know about the COVID-19 probable solution, और हम जो है वो मुख्तलिफ किस्म के in true that which one is the ultimate solution. So you have taken multiple items, okay?
ठीक है हामिद साहब. So I think
no one is actually giving you a statistical significant results. जी clear हो गया?
Yes, I think इसको हम आइसोलेशन में नहीं देख सकते, बल्कि इसके साथ बाकी थ्योरीज जैसे आपने कहा.
क्लियर हो गया मसूद साहब?
जी हामिद साहब, मेरी आवाज आ रही है आपको?
जी आपकी आवाज आ रही है.
तो इसका मतलब ये है कि हम इसको आइसोलेशन में नहीं देख सकते, मतलब इसके साथ हमने बाकी फैक्टर्स को साथ में देखना होगा.
एग्जैक्टली हम जो है ना, अब डिपेंड करता है ना कि आपका मॉडल जो है, आपने वेरिएबल जो लिए है. फॉर एग्जांपल यू हैव मल्टीपल वेरिएबल मॉडल और यू हैव सिंगल वेरिएबल मॉडल. अगर आप रिग्रेशन यूज कर रहे हैं और उसका इम्पैक्ट देखना चाह रहे हैं, सो देन इट मस्ट बी इन कंबाइंड, इट कैन नॉट बी इन आइसोलेशन. अदरवाइज ये तो फिर डिस्क्रिप्टिव स्टडी हो जाएगी, फिर इम्पैक्ट वाली स्टडी नहीं होगी. सो इन केस ऑफ टू फाइंड आउट दैट आइदर चेंजेस इन वन वेरिएबल इज बिकॉज ऑफ अनदर वेरिएबल, so you must have a statistical significant relationship. If you have statistical significant relationship, then you can go for forecasting or prediction. If it is not statistically significant, then you should stop here. It means that the variable that you have chosen, ठीक है, वो ठीक नहीं है. It has not been explained, or the theory जहाँ से आपने ये variable लिए, the theory is obsolete and that is not explaining this phenomena in this context. ठीक है, हो सकता है ये context change हो तो नहीं explain हो रहा, problem solve नहीं हो रहा. So I will go and I will take another theory variable, and this is your research, and research is done. Accepting a theory or rejecting a theory, in either case your research is done, and it is not necessarily that you will always come up with significant results. This is a very wrong perception, that you will always come a significant result. You will always prove that the theory is significant. You just let me share you. In most of the researches, there is some sort of a misconception that we try to, or we force to make our results significant, which is very much wrong. The reason is that most of the theories are developed in foreign countries with a very much different culture, in a different organizational setup. And you take the same theory and the same variable over here, and you are going to test those variables. So how you can expect that those variable will show you a much more good significant results? So from the very start of the day, because you people are at a very early stage and learning these things, our interest being a researcher is not to find out a significant relationship. Our interest is to find out a relationship, if that is significant or that is insignificant. If that is significant, it means that we will be able to we will give a policy recommendation to the ultimate stakeholder to use these models for the forecasting purpose. If you come to the conclusion that no, there is no relationship, it means you have verified and you have proved the particular theory, that this theory is not explaining this context or this organizational setup or the problem, the phenomena under investigation. So the better is to go and see what other theories are available. Or if there is no theory, then this is the best case. You should go for qualitative study, and you should ask the people that why your behavior is not explained by these factors. What is the reason that you fail to, or you do not opt for a positive response, or is not being solved with this particular strategy? It means there is something else that the people are actually interested in, and you are asking something different because you are following a theory. So the better is to go and ask and find out new things. This is actually the beauty of research, and that's why in the very first, in the very first lecture, if you remember, I have shown you in the very first lecture a diagram, and that is very much continuous in nature. Like the research process never ends, and it's a very continuous process. Like just see this diagram. Okay, you come here and you have collected data, you have analyzed the data, you have interpreted the data. Okay, let's see. Read this option. Refinement of the theory and implementation of the theory. Like if you come to prove that yes, there is a significant relationship between X and Y, so then this is applied, and just go put it into a place in your organizational setup and then make a policy on that. Okay, but if you fail to find out a statistical significant relationship, it means you need to go and find out in depth the probable causes of, because the existing factors that are known so far is not explaining the behavior of this particular phenomena, and you fail to get the solution of this particular phenomena. So now you need to go for a pure research. Pure research, it means that you will go and you will start taking data, observation from the people, observing the people, that why I have increased the salary, why you people are not motivated. This is a big question. For example, if I'm doing a research in banking sector, I'm going to increase your salary, but still you are not happy with that up to the level that the other public sector organization employees have. The reason is what? The reason is not because of compensation. The reason is what? The reason is a permanency. The reason of job security. The reason is permanent nature of the job. That you have not considered in your model. So that's why even increase in the financial compensation is proving no motivation on the other side, and the results are insignificant. So now you should go into the field and ask the people that why you are not motivated. What other thing can make or bring motivation in you other than the financial compensation? So definitely you will add new things to your research, and this is the process. This is how the research is not going to in a very conclusive stage, and we cannot conclude it. I hope that you got
Hamid said this is beautiful.
Masood Saab, you are clear now?
Oh, so Hamid said this is really beautiful. So we need to find relationships. Zaruri nahi that relationship is a significant one, or
it is not necessarily a positive, significant or not. Exactly. And believe you me, there is a 99% misconception among the people that they want to force the models to have a significant relationship. Otherwise, they believe that I'm doing nothing, or my research is actually with having zero output, which is a totally misconception.
Sir, I have got two questions. Can I continue?
Should we proceed?
Yeah, yes, Hamid said it's
So
okay for me. I don't know.
Please.
Yeah, sir, I have got two questions, sir, two different questions. Yeah, the first one is that you did discuss earlier when you started your lecture that you have these models working on this COVID-19 predictions and everything. So your predictions and today's situation, do you think they are same? Because at least in Pakistan, we are having a different figures as compared to the situation. We are dropping down the cases, dropping down the deaths, but overall the situation is not that. That's the first part of my question. The second part is that the research I did earlier on COVID-19, will that be in same category? Like if I go for making it finalized, so I'll be having the same sort of stata or SPS, the one we are discussing, or regression model, or that's some different thing?
Yes. We will be applying the same model. We are going to have, and that's why I am delaying it, so that you must have you have an understanding of these things, and then when you will do it, it will be much more practical for you. So you will have these things. Your first question is that you are absolutely right. But actually, I am making my prediction and I'm comparing it with the actual data, the data that has been provided on the website of the government. So I'm comparing, like I'm not comparing it with the actual number of cases. I have taken the data and I have done a prediction for the upcoming almost 20 days time period. And And believe you me, those 20 time period was actually originally achieved by the data. So for the real cases real situation is concerned, that is a different, obviously. But the reported cases and the reported early cases and later on after prediction the reported cases, that was almost in line with the prediction.
All right. See, what I am taking, like, I'm just
Have you
working on
got
that world.
my answer?
Yeah,
You are
yeah, I
hearing
got
me?
the point. Yeah, exactly. I got the point. What I meant to
Am-
say, like, as referring Worldometer, which is the most famous site these days for the data. I mean, like, there are few countries, they do think that the data is being manipulated, and Pakistan is one of these countries, including Iran and Saudi Arabia and China, of course. So the data right now, Pakistan is showing the cases of 3,500 as compared to it was earlier in 15 days, 6,000. So it seems the data is being manipulated by the authorities, by those figures. And originally, if take for example, Dr. Hamid has got some predictions. So your prediction and today's Pakistan data, is that matching, or do you have any discrepancies over there?
No, actually, my prediction, or even you can do it, or even we can do it, but actually it's too early to perform those sort of analysis. We will do, and I will show you the results. Actually, the issue is that whatsoever the data is showing, like either it is showing increasing trend or it is showing decreasing trend. Based on those increasing trends or those decreasing trends, we are actually taking the forecast based on the prior data. If that is showing increasing trend, so I have actually personally computed the increasing trend when there was early increasing trend. There was about the cases of 90,000, and then it's jumped to almost, so when I forecasted, it's went to almost 150, 150,000. So at that time, I have almost forecasted near to 150.
Right,
So
right,
that
got the
was
point.
actually based on the data. So the forecast or these analysis are not something that can find out that someone is doing actually manipulation in the data or someone is not doing manipulation in the data. It would be possible in that case if you got the actual data in the reported data. So we are actually making our whole analysis based on the reported data. So whatsoever
Hmm.
being done with the reported data, so our forecast is accordingly will be biased. So whenever we are doing statistical analysis, so we do add one limitation. When we do add one limitation, I have a thesis somewhere where I used to mention, and I asked the student to mention that the reliability of these results totally depends upon the data, the nature of the data that has been taken from the third party. If the data provided is not actually correct or manipulated, so definitely my result will be manipulated. My result will not be that much reliable. So
Right,
this is
sir.
the
Thank you so
limitation.
very much,
This is
sir.
our limitation.
Thank you so very
But
much.
we can minimize this limitation by collecting the primary data, first-hand data. Okay, let's move towards the F statistics, and let's discuss the F statistics. What is the F statistics? What the F statistics shows? Or either today it's enough for today. Enough for today. Yes, I got your mic. So from that I understood that you want to make me enough for today. Okay, no problem. Let me stop